In this example, we are asked to show that the product of two rational numbers is again a rational number. So let's start by listing our assumptions or our axioms here. So in this example, we have two numbers. We don't know what they are, but we can call them, let's call them, let's say P and Q, and these are rational numbers. Remember the symbol for the rational numbers is a boldface Q or a blackboard Q. So these are rational numbers, and what does it mean to be a rational number? Well, let's remember. So if P is rational, then P is equal to the ratio, that's where the word rational comes from, ratio, the ratio of two integers. So it's equal to m over n, where what? M is an integer z, and n is an integer that is not 0. So it cannot be 0. It's a non-zero integer. Okay, and actually you can make some changes to this definition and get an equivalent definition if you like. For example, you could insist that the integer n is strictly positive integer, and then that's okay because the sign, the plus or minus sign of p, will come from just m itself on top. All right. And really, this is all we need to do because now we're going to have our two numbers p and q. We're going to multiply them together, and we're going to justify that the product is itself a rational number. So this is not part of the proof. Okay, this is just me gathering my thoughts before I attempt to write the proof. So this is not something that you would turn in with your proof. This information here. Let me even draw a line here. You can draw a little line for yourself, and then what comes next? This is what you would turn in if you were asked to do this as an assignment. So our proof, by the way, that means we have to restate all this in the proof, right? And we have to write it in complete sentences. So here's our proof. Let's let P and Q be rational numbers. All right. You can use some symbols here, like you can use this notation if you want, but I'm going to write this one out in all words, all in words and sentences. So this is what we have. Now what we do is we can unpack the definition of rational numbers just like we did up here. We have to do it for P and Q though, right? So let me write it this way. So then there exist integers, let's call them M, N, R, and S. M, N, R, and S such that, and then we can say P is equal to M divided by N, and Q is equal to R divided by S, and then we should say here where N is not equal to 0 and S is not equal to 0. So neither denominator, N nor S, is equal to 0. Okay, now all we have to do is multiply these together. So the product, P times Q, is equal to the product of M times N, M over N, sorry, times R over S. This is just by replacing in the definitions that we just wrote down, right? So replacing P and Q by their definitions. And then we know how multiplication of fractions works. We just multiply straight across, right? MR over NS. And what do we have to say here? To be sure that this is a rational number, we just have to say that these two numbers are integers. The two parts of the fraction are integers. So we'll say it this way, where M times R and N times S are integers because they are the product of integers, right? So because they are the products of integers. And we have one more thing to say, right? The last thing we should say then is that N times S is not 0 since neither N nor S is equal to 0. Okay? And so this is it. This is pretty much just straightforward unpacking of the definitions. We do have to draw a conclusion. We have to finish our proof, right? So we conclude, this is a good way to end a proof, so we conclude that the product P times Q of rational numbers P and Q is itself a rational number. Alright, and as always, when we finish our proof, we make sure the reader knows that we are done.